Okay, so at this point you should have done the other two examples. So we have 700,800 here. Again, we're going to count from the right side. So I'm going to bring my cursor in. You can follow along here. The first non-zero I encounter is 8. Everything after that to the left counts. So that's 8, 0, 0, 7. That's 4 digits, which means I should have 4 significant figures. For this last one, 9,980 kilograms, again, we're going to count from the right, so watch my cursor. The first non-zero I see is 8, so everything after that to the left counts. 1, 2, 3 significant figures. That's essentially all significant figures is. If there's a decimal absent, you start from the right, start counting after the first non-zero, everything to the left counts. If your decimal is present, you count from the left side. The first non-zero you hit, everything after that counts. That's how it works. Alright, so why are significant figures important? Because you're probably thinking like, this is the dumbest thing I've ever had to learn. And by the way, I'm not a huge fan of significant figures myself. It's not something I really enjoy teaching, but I think this example will help you like understand why significant figures are relevant in a laboratory and why it is something that we do enforce. And when I first started teaching chemistry, like I really didn't understand it that well, and I didn't like enforce it. But now I've been teaching it longer, and it really does come up in labs and other things later on that like we need to learn about. So I'm going to show you a quick video on YouTube. So I'm just going to drag it into the browser here, and then we will I'll let you guys watch it, and then we'll take the exit ticket. Alright, so this guy's name is Tyler DeWitt. He's actually does a lot of stuff on chemistry that I think is pretty good. He's kind of a big hand talker, which you'll see in a second is like kind of annoying. But I think he does a really good job in this video talking about the significance of significant figures. So we'll just watch together and then we'll kind of talk about it afterwards. And then you guys will take an exit ticket.
Significant figures. I mean, really, you've learned all these rules about how to multiply and divide, how to do addition and subtraction, when a zero is significant, when it's not, and how to deal with decimal places. Okay, that's great, but it's such a pain in the neck, really. So what is the point of significant figures? If you're wondering this, I don't blame you. Well, for one thing, significant figures are useful because they tell us how to round. So we don't have to worry about whether we should round to 1 or 2 or 3 decimal places. So that's kind of useful. But the real point is more important. The real point of significant figures is to make sure that the answer you get, like from a math problem, isn't more precise than the numbers you started out with in the first place. This is a little bit tricky, so let me tell you what I mean by it. Most of the math that we do in science is with numbers that are measurements, right? So it's like the
Aren't his hands like the funniest thing ever? Alright, anyways, moving forward.
amount of liquid in a beaker, that's a measurement. Or the mass of a bunch of chemicals, also a measurement. Or maybe like the amount of pressure in a gas tank. All these are measurements. Now when we're taking measurements, some measurements can be really precise and others can be not so precise. Let me show you what I mean. Let's say that I have a rock here, a generic rock, and I want...
So this is the really good part of it. I really think is very useful. So make sure you're paying close attention to this part because I think it's a great example that I've thought of before, but like didn't express so well. Okay, so watch this.
to find out what its mass is. I can weigh it in a way that's going to give me a precise answer, or in a way that's going to give me a not so precise answer. Here's what I mean. I could take this rock, and I could put it on a plastic toy scale from my little sister's Barbie scientist playset. Okay? I do that, and I get the answer of 82 grams. That's the mass of the rock as determined. Take the rock and put it on an expensive NASA rocket scientist laser scale. Costs $10 million, but the laser scale gives me this answer. It says 82, similar to the Barbie playset, 0.1039217 grams. All these extra numbers are here because the scale, the laser scale, is much more sensitive, and so it gives me a much more precise number than I get from over here. So I can say that my Barbie scale number, 82, not very precise, as compared to the NASA laser scale, which is super precise.
I want to get this idea in your head that precision and accuracy are two different things. This number on the left isn't that much, this number on the left and this number on the right are both accurate, right? They're both around 82 grams. Okay, so they're both pretty close to the weight of the rock. But you can see the number on the right is a lot more precise. Precise would be like all the way to all these decimal places, while this one only doesn't even have a decimal place. Okay, so accurate, both of them. But one is really precise and the other is not very precise. That's the difference between accuracy and precise.
Okay? Now, I've got these two values for the mass of the rock. Let's say that I want to use the mass of the rock to determine its density. To do density, I'll do mass divided by volume. So let me take the mass from the Barbie playset here. Okay, so I'll take 82 grams, that's the mass, and then I'll need to find out the volume of the rock. So maybe I'll use like a graduated cylinder, also from the Barbie playset, and find out that the volume of the rock is 82 cubic centimeters. I do this math, and the answer that I get is 1.952380952 grams per cubic centimeter. Now check out this answer and check out the numbers that I started with. This is a problem. And here's why it's a problem. Because I started with these two numbers that were not very precise. I measured both of these with plastic science equipment from the Barbie playset. But then the answer that I got is super, super precise, or at least it looks super precise.
I think that's a really important point. A lot of you guys do this because your calculators don't know when to stop. And they're such good calculators, they can give you like 7 or 8 decimal places. That's not necessary when you're working with numbers like this. Okay, so I think he's actually got a really good point here.
This answer here looks like it's so precise that I only could have measured it with a super expensive NASA laser instrument. Okay? If you think about it, this doesn't make sense. It doesn't make sense to start with these really imprecise numbers and end up with a number that is so precise, I only could have gotten it with really sophisticated, sensitive equipment. So this is where significant figures come in. If I'm using significant figures, I'll do the same calculations, but I'll realize that there are two significant figures in both of the numbers that I'm starting with, which means that my final answer here can't have more than two significant figures. So instead of 1 point all of this stuff, I'm only going to get 2.0 grams per cubic centimeter.
So right there, 82 has two significant figures, the 8 and the 2. And so does 42, the 4 and the 2. That's two figures. So your answer also needs to have 2. So 2.0 is the closest number with two significant figures to 1.952380952. Okay? So it's either, the answer is either 1.9 or it's 2.0. And it's 2.0 because this number is closer to 2.0 than 1.9. That's all he's saying. But with like his hands waving all over the place like he's some sort of wizard.
And now in this case, the answer that I get isn't more precise than what I started with. So this is what I get without significant figures. And now when I use significant figures, I get an answer that is just as precise, but not more precise than what I started with. So it actually makes sense. Now, on the other hand, if we started with two super precise numbers, if we measured both the mass and volume with super sensitive equipment, it would be totally fine for us to get an answer that itself is very precise. That's only because the starting information here was precise, so the answer too can be precise. This is with the correct number of digits based on significant figures. I hope you're beginning to get the hang of this. And to help you, I want to give you an analogy to the everyday world that might really make this all come together for you. Okay, so imagine that you're at home and you're trying to meet up with two friends who are hanging out.
I think we're pretty much done here. So what we're going to do now is I want you guys to take the exit ticket. Oops. Hold on one second. Sorry, Tyler. See you later. Okay, what I want you to do now is work on your exit ticket. And then after you finish your exit ticket, there's an article over next to the periodic table that you can work on. Or you can take out your books and like read for a while until class is over. The exit ticket is going to be really short. When you finish the exit ticket, please turn it into your class period folder. Then when you finish the exit ticket, you can read an article about the recent discovery of waters on Mars. There's 5 questions that you can answer after you read the article as well. You can just hold on to that. I'll take a look at it tomorrow if you guys want to discuss it or anything. And if you need to work on something else for another class, like if you need to read your book for English, you certainly can do that for the rest of class as well. Okay, thank you guys again for your attention. Have a good Monday.